In this video, we're going to talk about the gamma function. All right, gamma function. And this is the first video on gamma function actually. Now, the gamma function of x, this is a symbol, gamma of x. So gamma of x is equal to the integral from 0 to infinity of t to the power of x minus 1 times the exponential function e to the power of minus t dt. All right, this is the gamma function. This is the definition. There are a lot of proofs in this gamma function, but I'm not going to go through any of them. Okay, yeah, I will not go through any of the proofs in this particular video. What we are doing here is just to apply the formula and solve problems. That's what we are doing basically. Okay, and this is convergent for x greater than 0. They are convergent for x greater than 0. Now, take note of this. If x is equal to n, and n is a positive integer, where n is a positive integer, then we have the following. Gamma of n plus 1 is equal to n gamma of n. That's 1. Gamma of n is equal to n minus 1 factorial. So from here, if n is equal to 1, okay, if n is equal to 1, if n is equal to 1, we have gamma of 1, right? So gamma of 1 will be equal to 1 minus 1 factorial. What's 1 minus 1? That will be 0. So we have 0 factorial. And 0 factorial is equal to 1. So gamma of 1 is equal to 1. Take note, gamma of 0 is infinity. Yes, gamma of 0 is infinity. There's a proof for that. The gamma of 1 over 2 is the square root of pi. So take note of all of this because we're going to make use of them to solve problems later. I want to evaluate gamma of 7. What would this be? Actually, gamma of 7 is 720, which is 6 factorial. This is simply the integral from 0 to infinity of t to the power of 7 minus 1. Okay, because that's what we have here. So 7 minus 1 will give me 6. E to the power of minus t dt. So if I evaluate this integral, I will get 720. But there is no need to evaluate this integral because I already have a formula for it. It's simple. Gamma of 7 is, just use this formula, is simply 7 minus 1 factorial, and that's 6 factorial. 6 factorial is 720. 7 times, 6 times 5 times 4 times 3 times 2 times 1. And that also means that gamma of 8 will be equal to 5040. You can also check that. So for example, I am giving gamma of 7 as 720, right? What is a gamma of 6? Given that gamma of 7 is 720. Okay, see something. Gamma of 7 can be written as, using one of these identities, gamma of 6 plus 1. True or false? Look at this identity very well. Look at this identity very well. We have gamma of n plus 1 equal to n gamma of n. I'm solving this problem right away. Just watch me. So if I make gamma of n the subject of the formula, it will be equal to gamma of n plus 1 all over n. So I am trying to determine gamma of 6, given that gamma of 7 is 720. So gamma of 6 is actually gamma of 6 plus 1 all over 6. That's the idea. And 6 plus 1 is what? Is 7. So this is gamma of 7 over 6. That means we just divide 720 by 6, I will get gamma of 6. Let's divide. 6 divided 7 is 1, remaining 1. 6 divided 12 is 2. So the answer is 120. So gamma of 6 is actually 120. That means that given that gamma of 6 is equal to 120, I can determine gamma of 5, because gamma of 5 will be equal to gamma of 5 plus 1 all over 5, using this identity that we have. This is it. I got this from this. So this is 5 plus 1 is 6, and this is gamma of 6, which is 120. So divide 120 by 5, and you will get 5 into 12 is 2, remaining 2. So that will be 24. So gamma of 5 is 24. What is gamma of 3 over 2? Remember I told you earlier, of course I've cleaned it, that gamma of 1 over 2 is the square root of pi. What I will do is to write this 3 over 2 to contain 1 over 2. Yes, it is gamma of 1 over 2. What will I add to 1 over 2 to give me 3 over 2? That's 1. Yes, 2 times 1 is 2. 2 plus 1 is 3. So gamma of 3 over 2 is actually gamma of 1 over 2 plus 1. Okay. Now, how do I evaluate gamma of 1 over 2 plus 1? I can use this. In this case now, n is 1 over 2. 1 is still 1. So this means I'll be writing 1 over 2, gamma of 1 over 2, because n is 1 over 2. Recall, what is gamma of 1 over 2? It is root pi. There is a proof for this, but I'm not talking about the proof in this video. Gamma of 1 over 2 is what? Root pi. So this will be 1 over 2 into the square root of pi. So what is gamma of 5 over 2? It's simple. I can write gamma of 5 over 2 as gamma of something plus 1. I'm using this. I can write it as 3 over 2 plus 1, because 2 times 1 is 2 plus 3 is 5. What is gamma of 3 over 2? The same procedure here, using the same formula. It will be 3 over 2 gamma of 3 over 2, because gamma of n plus 1 is n gamma of n. So gamma of 3 over 2 plus 1 is 3 over 2 gamma of 3 over 2. We have deduced the value of gamma of 3 over 2, and that is what? 1 over 2 root pi. So gamma of 5 over 2 is 3 over 2 times 1 over 2 root pi. Everything here is 1 over 2 into the square root of pi. And that will be 3 over 4 into the square root of pi. So this is the value of gamma of 5 over 2. Now, let's see something. What is the value of gamma of 9 over 2? I want to show you something. Gamma of 9 over 2. This is simple. Okay? This is the gamma of 7 over 2 plus 1. Do you agree? Yes, it is. Now, just watch. By this formula, okay, n is 7 over 2. So we'll be writing 7 over 2 gamma of 7 over 2. The question remains, what is gamma of 7 over 2? We have not even deduced that before. Gamma of 7 over 2 now is the problem. We have a 7 over 2 already, times, without thinking too much, gamma of 7 over 2 is actually 5 over 2 gamma of 5 over 2. Do you agree with me? Yes. Because 7 over 2 is 7 over 2 plus is 5 over 2 plus 1. So that I will write that as gamma of 5 over 2 plus 1 as 5 over 2 gamma of 5 over 2 using this very powerful formula. So it continues. 7 times 5 is 35 over 4. What is gamma of 5 over 2? Of course, we've gotten that. So let me not just proceed. If we had not solved for gamma of 5 over 2, we only know gamma of 1 over 2. We will keep going until we get to gamma of 1 over 2 and then substitute root pi for it. You get the point now. So this is simply times 3 over 4 root pi. What would that give me? 35 times 3, this is 15, take away 1. 9 plus that one is 10. 105 over 16 into the square root of pi. Now, let's talk about negative values. What is the value of gamma of minus 1? To do this, we are going to come from here. Okay? We are coming from here. I want to make gamma of n the subject of the formula. And that will be gamma of n is equal to gamma of n plus 1 all over n. Okay, so we make use of this to determine negative values as well. That means if I'm using this formula, minus 1 is n. So this is actually equal to gamma of minus 1 because n is minus 1 plus 1 divided by what? N is minus 1. Minus 1 plus 1 is 0. So we have gamma of 0 all over minus 1. And I told you earlier that gamma of 0 is equal to infinity. So this is actually infinity. It will interest you to know that gamma of minus 5, for example, is also infinity. This is gamma of minus 5 plus 1 over minus 5. Minus 5 plus 1 is minus 4, right? So this is gamma of minus 4 over minus 5. And that is actually minus 1 over 5 into gamma of minus 4. What is gamma of minus 4? This is simply minus 1 over 5. For gamma of minus 4, it will now be gamma of minus 4 plus 1 all over minus 4. You get the point now? Okay, yes, that's what it will be. And minus 4 plus 1 is minus 3. Okay, so we have minus, we cancel minus 1 over 20 gamma of minus 3. What is gamma of minus 3? It's simple. This is 1 over 20. Gamma of minus 3 is simply gamma of minus 3 plus 1 over minus 3. So this will give me minus 1 over 60 gamma of minus 2 because minus 3 plus 1 is minus 2. What is gamma of minus 2? This is minus 1 over 60 into gamma of minus 2 is gamma of minus 2 plus 1 over minus 2. Okay, so this is minus cancel minus, we have plus 1 over 120 into minus 2 plus 1 is minus 1, gamma of minus 1. Interesting. And what is gamma of minus 1? That's infinity. So everything will go towards infinity. So you take note now. Let's add that to this. The gamma of minus n, okay, is actually infinity. What is gamma of minus 1 over 2? Using the same identity, the first one that we have here, this gamma of minus 1 over 2. In this case now, n is minus 1 over 2. So we'll be having gamma of minus 1 over 2 plus 1 all over what? Minus 1 over 2. What's minus 1 over 2 plus 1? That will be positive 1/2. That's 1 over 2. So this is, what is gamma of 1 over 2? It is what? Root pi. Don't forget that. So this is simply a root pi over minus 1 over 2, which is minus 2 root pi. That's the gamma of minus 1 over 2. So likewise, what is gamma of minus 3 over 2? it will be gamma of minus 3 over 2 plus 1 divided by minus 3 over 2, right? Minus 3 over 2 plus 1 is actually 2 times 1 is 2, 2 minus 3 is minus 1. That's actually minus 1 over 2 all over minus 3 over 2. And we have determined this already, gamma of minus 1 over 2, which is minus 2 root pi. So we'll be writing minus 2 root pi divided by minus 3 over 2. This cancel this. These two will go up. Multiply these two, we have 4 root pi all over 3. So gamma of minus 3 over 2 is 4 over 3. That means if we are to determine gamma of 5 minus 5 over 2, for example, it will be gamma of, minus 5 over 2 plus 1 all over minus 5 over 2. And this is gamma of minus 5 over 2 plus 1 is minus 3 over 2. This is 2 minus 5 is minus 3. So gamma of minus 3 over 2 divided by minus 5 over 2. So what is here? This is 4 root pi over 3. So we have 4 root pi over 3 divided by minus 5 over 2. Okay, so what would that give us? That will give us, these two will go up to multiply this 4, and that will be 8 root pi. Of course, the minus will also go up. Then this 3 will multiply this 5 to give us 15. You get it? So it is minus 8 root pi over 15. So you can go on to determine gamma of minus 7 over 2, minus 9 over 2, and so on and so forth. Having gotten to this level of the study of gamma function, it means that integrals of this form, the integral of, let's say, x to the power of 2, e to the power of minus x dx, can be evaluated. That's from 0 to infinity, can be evaluated. Yes, I can easily evaluate this integral. It looks kind of heavy, kind of cumbersome at first sight, but the knowledge of gamma function reduces the whole integral to something that is very, very small. We can handle it easily. So if you compare the general form with the integral of t to the power of x minus 1 e to the power of minus t dt from 0 to infinity, we say this is gamma of what? X, right? So compare. This will be the integral from 0 to infinity of x to the power of 3 minus 1. Because 3 minus 1 will give me 2. E to the power of minus x dx. So this is simply gamma of 3. That's what it means. And what's gamma of 3? Gamma of 3 is simply 2 factorial, and that's 2. So it is so funny and so interesting to know at the same time that this integral is equal to 2. Gamma of 3 is simply 3 minus 1 factorial, and that's 2 factorial. Or if you use the other identity that says gamma of n plus 1 is n factorial. So 3 is 2 plus 1, and that would be 2 factorial. I just introduced a new identity. I didn't write it earlier. Yes, you can add it to the ones I gave. Let me write it again. Gamma of n plus 1 is equal to n factorial. It's almost similar to this. So this is equal to 2. So what then will be the value of this integral? The integral from 0 to infinity of x squared e to the power of minus 2x squared dx. Are we going to say it is gamma of 3 minus 1? No. Do you know why? What I have here, the form of this integral is not the same as the form of this integral. Hence, we will have to do a modification of this integral. Yes. So just keep watching. In the next video, I'm going to handle integrals like this. Yes. So I've introduced to you how to handle integrals like this using the gamma function, when the integral is exactly in the form of the gamma function definition. But when it is not, there is a modification. So that's what we'll talk about in the next video. Just keep watching. Subscribe, like, and share this video to your friends and to your classmates.